Hi, my name is Ethan Hall. I work at LinkedIn on their Build Tools team, and my team specifically focuses on Gradle implementation across LinkedIn. This talk is going to cover a little bit of two different things. It's going to talk about a little bit of philosophy for development of infrastructure code, and then we're going to go through what I call the life cycle of different developers in Gradle. So, but before we do that, I want to have a quick raise of hands. How many people write unit tests for their production code? All right, I was hoping more, but it's fine. How many people have a style guide at their company? Okay, even less. How many people write tests for their infrastructure code? So this is Ansible scripts, Chef, Puppet, things like that. Okay, there's about 4 or 5 people that raise their hand. The reason I talk about this is that in reality you should treat your production code with the same quality. You should treat it as the same quality as your infrastructure code. That's because imagine if you have a bug in your config management system and you accidentally delete your database off your server in production because you didn't test that the apply didn't delete the database ahead of time, which some people have done by hand and deleted petabytes of data off of their Hadoop clusters, says some Reddit thread. So it can happen when you least expect it. And if you treat your production code and your infrastructure code the same, that means you really get a lot of quality out of it. And people won't go through and have this idea of, I can just do this, it'll live in the corner, no one will ever look at it, and no matter what happens, it's fine. And I think Luke Daly talked about it a little bit yesterday during the panel, where if you treat your build scripts and your code like that as high quality, first-class citizens, you're going to get a lot less people that don't understand what's going on. So if you don't have any tests, for instance, for your infrastructure code, and someone comes on, they don't know if they break something like that. And if you have a lot of tests, they're like, oh, if I add new functionality, I should add a test because there are already tests written. So one of the things that we like to do, at LinkedIn at least, is all of our infrastructure code also has unit tests to go with it. Maybe not 100%, but we do what we can. We have a style guide that gets applied. So if I make a change to the code base and I push that validates the style guide, my commit gets rejected straight away. Doesn't go through CI, does not pass go. I have to fix it. We go through 100% review, so if I make a change, I can't just push something simple in. You have to go through and review the change. Someone else has to do it and validate that what's happening is good and it's not going to break everyone else. And finally, we automate. Like, you don't want to go through and do manual testing for something because it takes a lot of time and it's error prone. So every infrastructure code change also goes through the same automation that a production code change would go through. Maybe it goes to a different place, but it does the same workflow and you can integrate with it the same way. So you don't have to think about, oh, is this production code? Is this infrastructure code? Is this play code? It all follows the same pipeline, same guidance, and I think if you treat your code like that, you'll have a lot higher quality code base going forward and people will start to understand what's happening. And this kind of leads into the broken window theory. Pragmatic programmer talks about it. There's also a study done by a university that I forget the name of. We left a car in 2 different cities, the hood up, things happen to it. But basically what it comes down to is if you see things that are broken in a code base, you're not going to feel as bad if you break something. So if they don't have any tests and you don't write a test, they're not going to care, you're not going to care as much. If you've got inconsistent style guide across every file in your source tree, if yours is using 3 spaces for some unknown reason, then they're not going to care either. So as these things add up, it becomes harder and harder to change, and you run into problems with, especially if you're doing maybe a dynamic language, if you have tabs instead of spaces for Python, all sorts of weird things will happen in production versus at runtime or development time, especially just on different versions of Linux even can have problems. So if you don't apply a consistent quality to everything you write, you're going to run into these weird edge cases, and they're going to cause a lot of time spent debugging, solving problems in the future. And one of the ways you can help this is by using the Boy Scout rule, which is taken from the Boy Scouts and written about in 97 Things Every Programmer Should Know by Uncle Bob. Basically means if you check out a code base and you make a change to it, if you see something that can be easily fixed, just fix it. Don't worry about, oh, it's not my code base, it's not this. If you fix the code, commit it, the people that wrote it will be happy because you fixed something that they needed to fix, and it'll go forward and start patching the windows up, making things easier in the future for people to make better changes. And they won't know, oh, this code base used to have no tests, now it has all the tests. Life is good, things break, we know, stuff like that. I skipped a slide, I think. Nope. So, second part of this is we're going to do a kata. How many people have heard of a kata? Hands, okay, there's probably a dozen or so. Basically what a kata is you do something, you repeat it a few times so you get good at it so that when you have to do it in real life, you don't have to think about it, you can focus on the other problem that you're trying to solve. Comes from karate, and that's what you see them doing the same action over and over again. It's to get them so they don't have to think about what they're going to do. They just instinctively know if you're going to get kicked, you raise your hand up or something. I don't know, I don't do karate. But the last thing I want to leave about the philosophy part of this is you got to be pragmatic about what you do. So if you want to do, let's say your team decides we want to add 5% test coverage and we want to fix all of our style guide problems that we've run into. It's great, applaud you, but don't do them at the same time. Break them into 2 separate commits, 2 different reviews. So if I get a review and I have 2 things that are happening at the same time, I might not check all of it. If I know that it's mostly a style guide change, I'll graze through it really quickly, and I might miss something. But if I know that this commit right here was IntelliJ auto format, and the second one was I'm adding tests, which means I have to refactor a little bit, I'll spend more time looking at what's going on. It also makes the diff a lot nicer. So if you're doing, especially like style guide where you're moving code around, you'll notice the diff will be impossible to read because every file will be changed. And you won't notice that I've changed a constructor argument a little bit. And then this is from Pragmatic Program, or not Pragmatic Program, 97 things every programmer should know. They call it Know Your Next Commit. Both Pragmatic Programmer and 97 Things, great books if you want to read them. They're fantastic, they're really quick, especially 97 Things. And the last I want to leave is don't ignore business needs. So if you can have the highest quality, you always writing tests, always 100% coverage, blah, blah, blah. But if you go out of business next week because you couldn't release a feature, that doesn't mean anything. So if you're going to make changes and you can't meet the timeline that your business needs, you can always say, I can't write this test that I need, but I've tested that it works. I'm going to do it in the next sprint and tell the business, hey, I need a little bit more time to finish up what I worked on last time. I got you the production code, but I need to make sure that we don't let anything seep into our code base. So in my past, showing people Gradle, teaching them Gradle, I've noticed that people go through basically 3 phases of development for plugins. They do inline things, set version numbers, set this, that in the script. They'll realize that they can't do it to everything, or they don't want to copy and paste it all the time. So they'll make a script plugin, basically you apply from and then a path on the file system. And then finally they'll make a binary plugin, which is really the holy grail of enterprise development for this. And we'll talk about, as we go through the exercise, we'll talk about why you don't want to do some of these things, or why you want to get to binary plugin versus just stopping at the script where you can apply it by URL or do get some modules. And in live demo fashion, it's always fun to show someone how it's going to work. So after this, basically is going to be, I'm going to pull up IntelliJ, and I'm going to go through taking a really simple file. I'm going to make a script you can apply. I'm then going to convert it to a plugin that you create, add some tests, publish it to Artifactory, pull it down from Artifactory, and show you how you can do that process. The Git repo down at the bottom has the code I'm working off of, so you can feel free to clone it if you want to try along at home later. It has a Vagrant image that has Artifactory pre-running, so if you just start your Vagrant image, you'll get Artifactory running, and it has the ports already listed in it and the IP addresses, so you don't have to configure that for you, so helpful. There's also some cheat sheets if you have some questions about some things we're going to do. So without further ado. So this is my plugin that I'm going to write. What I really care about right now, can you guys read that in the back? Does it make it bigger?
Yeah.
View. How about that? Cool. So, oh, this is going to be painful. I've got things I need to do on the side. That's not. I have to make new files. That's not going to work. I'll just make the font big. Can you guys read that at the back? Cool, thanks. So I've got a build script right here, and I'm only going to care about the version part. I'm setting the build directory so that I can tree a file structure and it's all in one spot so I get less noise. But I'm going to focus on this version bit right here. So in reality, you wouldn't want to use something like this because the seconds are going to be in the version number, and so every second your build will have a different cache break, and you'll have spend a lot of time recompiling jars and remaking jars. You don't want to do that. It's going to be inefficient. So what we're going to do is we're just going to take this, we'll copy, and I'm going to go into the Gradle directory. I can't zoom that up. I'm going to do a new file. Just call it version.gradle, and just paste it. So here I've just copy and pasted the code, and I'm just going to change this version equal to apply. I also can't type, so I will have lots of typos. So I'm going to apply from a script. Here I've written root dir /gradle /version. Root dir is nice because you're giving it a fully qualified path every time. It's relative to your settings.gradle file, so you don't have to worry about if you're executing it from 3 directories deep or something like that. It's always going to be the same path. So if you're going to use a script, I'd recommend using something like root dir or file. Clean up the imports. You're probably wondering what's this thing doing here? Well, it's to keep the version numbers the same across different the 2 projects that I have. So if I didn't have this and just a new version or new date, they would have slightly different seconds, and that just was weird to look at. So I've put it in this extension here, defining init time to be local date time now. So here's my project. It's a pretty simple Gradle project. I've got 2 sub-projects. I've got a mystery sample plugin in it, some init stuff. So I'm just going to run Gradle build. Let it run real quick, and then tree the build directory from previous workthroughs. I'm just going to rerun that real quick. So you see we've got 2 classes, 2 jars, libs and libs, that have a version, they've been published, life is good. So now we've done the simple part. We've extracted this logic so that you can apply it from a script. You can apply it in some projects, not other projects, which are helpful when you have, one project needs this plugin because it's let's call it a C app. The other one needs a different one because it's a Java app. You don't want to have to do if project and do a bunch of weird stuff like that. So you can apply different scripts that are shared across all your plugins. So what we're going to do now is we're going to switch this from being a script which has no type safety, no nice things like that, to we're going to write an actual plugin that Gradle would use. So I'm going to go back into my IntelliJ, and I'm going to make a build source directory. And tell IntelliJ to refresh my dependencies real quick. Or refresh. If you can't see this, but there are dependencies for the build source. I'm recording my screen locally so that we can put it up in the video later if you want to look at it later. And so I'm going to do is make a quick file. I'm going to just build.gradle. I'm going to apply the Java Gradle plugin. So that's going to generate some, it'll tell me that I've had typos in my properties files that Gradle's going to try to consume. It'll apply some nice dependencies for me so I don't have to do any special stuff. So I can leave that empty. And if I just go to this, I can do source main main Java. So I personally like writing Java plugins because they're faster and you get a lot of type safety out of it. So if something changes, I don't have to worry about it in the future. My builds will just fail. So I'm going to just make a new class. Com example version plugin. I'm going to implement plugin. And type with the type project. So when you implement a Gradle plugin, you always implement the plugin interface, and then you can choose between project or a few other options, but most people always just use project. So this is going to give me something that I can apply by string. So if like apply Java, same kind of mechanism here. So what I'm going to do is I'm going to take this version file, copy, paste. It'll copy it over, but you know it's not going to work because it's not going to know what this init time thing is, and it's not going to know what this version thing is. So we're just going to tell it how to do it. Project.get extensions. So from this closure that I did, this is the extra extensions, extra properties. So I'm just going to take just going to retrieve it. Sorry, it's not big enough. Get extra properties dot get, and then init time. Save it somewhere. I know it's a local date time, so I'm just going to cast it to that. And then that, and here I've got access to project. So instead of using the dynamic property setter that Gradle's going to give me, or Groovy's going to give me, I'm just going to call project.setVersion here. So before I finish that, I'm going to delete this script. IntelliJ is nice enough to tell me that I'm using it somewhere. I don't care because I'm going to apply it. So I'm going to do apply plugin, and then I'm going to give it the fully qualified path to the plugin. It's not what I want. I want this. So I'm going to delete the build directory again. I'm going to run the build. Assume I didn't have any typos. Should work. So I have a mistake. My mistake is I'm going on the project. So when you do it like this, you don't have the inheritance you would get normally through Groovy calling .root project and going up the tree. So I actually need to do this on the root project. And if I rerun build, it should pass. Passes successfully. Tree build, jars are there, and life is good. So what happened there? When you add a build source directory, Gradle's going to output this output at the beginning of every build, and it's a little off the screen so you can't see it properly. What this is doing is basically Gradle's compiling something and adding it to the class path before the plugins get applied. So this is like the build script section for plugins you would apply. Normally, makes your life a little bit nicer. One of the caveats for this is, if you have a compilation error, you can't use Gradle to figure out what's wrong. You'll just see a stack trace. If you have a dependency problem, you'll see a stack trace, and you can't run any Gradle commands until you fix it, which is interesting because Gradle is going to use this to figure out what it needs to do in the plugins to apply to get dependencies. So it's a bootstrapping mechanism is what we're using. And so I'm going to make a directory, not module, directory. So I don't like using classes because they can change. I don't want to give someone something they can change that they can use. So I'm going to make a string name they can apply. Makes life easier. So if you change the class implementation, they don't have to worry about if you move packages or something like that. They just always use the string. So resources. So you put it in the resources directory, metainf Gradle-plugins. And then you just make a property file. The name before the .properties is the name you'd apply by. So we're just going to call it version.properties, or property. It's properties, typos. And implementation class. And then I can just copy this fully qualified path again, there. And if you want to know how to do that, it's Command Option Control C or Shift C in IntelliJ to copy the reference to a class. It's a useful one. And so in my build.gradle here, I'm going to stop doing that and just do -version. And going to go through delete, build. I guess I could run clean, would be easier. Build ran successfully. Tree build. Everything's working like we want it to. Cool. So now we've gotten to the point where we've got Java code written for a plugin that you can apply by a name, which is really nice because now you've discovered that someone else wants to use this code. So now that you've got this in a shareable state, we can just really copy and paste this. So I have another IntelliJ window open that has some boilerplate stuff. I'm going to delete that because we're not going to talk about it. If you want to see it later, we can talk about it later. Basically, I'm just telling it, use Groovy, version, publishing, some really simple metadata you can find pretty much anywhere on the internet really easily. And down here, I've got the credentials to publish to Artifactory that I'm running on my laptop. So I'm just going to do from this build source directory, copy, paste. It pastes, everything's the same. I haven't changed anything. I'm going to go back to my terminal. And in my second window, I've got this project. So just run Gradle W build real quick. Build, make sure it works right. I forgot to clean. So I have some tests written that don't pass, that were part of my cache that didn't get cleaned up after deleting the test files. So I built it, tested, it works fine. If I tree my Gradle directory, or not build, sorry, my M2 directory, you'll see that I've got com example plugin, sample plugin 001 published there. And so I'm just going to go back to this guy and delete all the source code. So now it's gone. And then you use what's called the build script. So you're going to tell Gradle, I need to actually load some stuff up before my script can run so that you actually know where everything is. I'm just going to do it up here. IntelliJ is kind enough to help me autocomplete so I don't have to make so many typos. So I'm adding something on the class path, and I think I called it com.example.plugins plugin. And I'm just going to use plus so we get the latest that's available. So now if I go back to the first project, so this is the project we originally started with. If I run Gradle W build, I've got some class loader conflicts. I'm not using the most recent Gradle edition, so my caching is probably broken. I'm going to stop the daemon. Okay. And then I'm just going to delete the directory to pull from. And then I'm just going to publish this guy real quick. Oh, that's why I didn't publish him. So I forgot to publish the artifact to my Maven local. Yada, yada, yada. That's why it didn't work. And if I run, hopefully everything works like it's supposed to. Cool. So the builds work. So now I no longer have this build script stuff showing at the top. I'm not compiling it locally. I'm not dealing with it this way. So this is something that you could then share to other groups inside your organization, making it so that you can reuse code as much as possible. But there's one thing that we're still doing that's a little weird. We've got this init, or this X thing, setting the time. We don't really want to do that, so let's fix it. So I'm going to go back to my plugins. So I've switched IntelliJ to the different plugin. I'm going to make a new plugin. Let's call it root version plugin. Thank you. So doing like I did before, implementing plugin, apply from, project dot. So we only want this to apply at the root project. So we need to validate that we don't apply this somewhere else. So we're going to do if not project dot get path dot equals project dot root project dot get path. Throw new. Let's do a runtime exception. Cannot to non-root project. Okay, that's going to compile now. Cool. And so now we're just going to do, like we got to the extension before, get extensions, dot get extra properties, dot, instead of doing the set, we're going to do the get, or instead of doing the get, we're doing the set. Use init time, then local date time dot now. So now we've set the property that we need to use. So in our plugin, which I'm going to make bigger before I forget, I'm just going to go project.root project.apply root version plugin.class. Oh, it's not know what to do. So I'm going to get the get plugins dot apply. So now I'm telling plugin to apply. I'm getting the root project, applying a plugin to it every time. Gradle caches plugin apply, so it's not going to keep applying it multiple times. So you only get the first time it's executed, which is nice. Usually you don't want to apply plugins to other projects, but for the sake of convenience and you're encapsulating this whole thing into one, it's nice. In my use case that I would usually use, I would have two plugins that you would apply, one at the base that would configure out, and then one that would do on every project and get the version. But we're going to flip this a little bit. We can fix it later. We can talk about it later. So I can go back to my IntelliJ. I can just delete this guy. And if I republish, it's working. So it would have thrown a stack trace because I would have been trying to get a property that didn't exist. So we know that it's working. But this is really a crappy way to know that something's working. It's worked on my one machine. Who knows if it's going to work everywhere else? So let's write some tests. So I'm going to go back to my plugin. I'm going to make a source main or source test Groovy. So I think like a lot of people here, they use Spock for their testing because it's a great framework. I'd highly recommend it if you haven't looked at it yet. So we're going to use, for this demo, Spock. Tell IntelliJ to make a test for me. It knows about Spock. Zoom in. So first thing I need is I need a project. I can use project build. So now I have a project I can use for my plugin, for my test. Def. So one of the nice things about Spock is that you can use strings. You can use spaces in your method name, so you don't have to do this weird underscore work. You can also use table format, so you can actually write one test that tests a bunch of data. There's one test that I've written, I think, 4 tests that have a total of 19,000 executions. So some pretty good reuse out of those 4 tests. I test all of my validation that I need. So when project.apply plugin version project.version. So right here what I'm doing is I'm asserting that version is not null. So if I go to run my test in IntelliJ, let's build it, do its thing. Green bars, nice. But I don't trust tests if they don't fail. So I'm going to make it fail on purpose. Cool, that's what we expect. So I also know that I have a property set in my root plugin that I'm going to be using. So I can't assert that the two times are the same because I'm losing some resolution. But what I can do is I can assert that the property pullout is roughly equivalent to the other plugin, or to the string I'm writing out. So I can use version. I think it's date time formatter dot from parse of pattern. I never remember the API. Well, I could type it out again, or I could just reuse it. So I'm going to go up to my plugin again. I'm going to extract out this constant, call it a version pattern. So now I can reuse it in my test. I need version plugin dot parse project dot version. I can save that off. Let's save it as something that's not parse. Let's save it as version so that we have something useful. Okay, so now I can write some tests. I'm going to use a loop in Spock. So I'm going to use chrono field, sorry, dot year, because I care about the year. Chrono field, and then I'm going to do month of year, or day of year, sorry, because we know that only one day in the year can be that number, so they would be roughly the same. If the day in the year, the other task in the computed value is the same as the one that was generated, they're the same day. So day of year. And then I'm also going to do chrono field dot second of day, because I only go down the second, so I don't need any more resolution than that. Dot each, and I'm going to do version dot get it. So I'm looping through it, equals project dot init time. So here I'm relying on the method missing, finding it up through the property. But I know ahead of time that this is going to work, even if I tell it it's going to break. So these should be the same, and they are. They work. So the reason it's not failing this test is because when you have a loop inside of Spock, you need to assert. So Spock doesn't know that a closure is going to have a value. It only checks the output of it. The closure doesn't evaluate some way that you need it. So if I do here assert that, the test should fail. And it didn't. That's interesting. Oh, that's right. I need to do get it. They weren't the same because they were different object types. Now it failed because I asserted that they weren't equal, but they're equal. So now I'll do it equal again. And then to prove that it does actually work the way that I say it does when I don't do typos, I'll run the test when it should have failed. Really? So it passed. We know it should have failed. So when you end up doing some looping in Spock, and you have a closure of some sort, be sure to do asserts inside of it so that you actually get Spock to trigger on that assertion.
You could do an every instead.
I could, but loops are, it's a closure problem, right? So if I have a closure that I'm going to accept in, maybe it's a parameter, I'm going to assert the values or what are coming into that parameter using some groovy magic. I always want to have the return type, so it's just safer to do an asserts.
Every returns true.
Right, but that's not what I'm not getting at that point. I'm getting at if you have a closure and you want to assert that a value inside of a closure is right, you have to assert. You can't rely on the return type. So my test is here. I could write another quick one for root that I'm going to steal from this guy. Zooming. Project.plugin. Let's do it the way you would in a script. Plugin apply. And then what is it? Root version plugin. And then let's just assert that project.init time is equal to project dot extension dot get your extra properties dot get init time. I forgot to run the write test. So let's run the write test, asserting that it's right, and then so we can do that. So we've now taken this plugin, we've written a test for it, we validate that it works right. We can now publish it to Artifactory. As it turns out, before I started the demo, I started an Artifactory instance. It's happily serving 0 artifacts. Yay. So if I go to my plugin, instead of publishing to Maven local, I've already configured it in the script that's provided to publish to this location. So we're just going to do publish. And that is right. I thought I spelled it wrong. We're publishing it to Artifactory. It all worked. So now instead of using local repo like we have here, I'm just going to go to the build.gradle and steal this URL. Instead of using Maven local, Maven URL. So if I go to my original project I've been working on, if I run this, I hope, oh, it didn't pull it down. I've got some Gradle caching happening, so I'm going to change the version numbers real quick to get a different version, so it has to pull it down. I could use refresh dependencies, I think, but I forget, specifically for build plugins. So change the version to be, here I'm going to change it to be 1.0.1. And there we go. We see that it downloaded from Artifactory properly, loaded the class path up, ran the build like we wanted it to. So let me take a step back here and go through what we've done. We've taken a build.gradle file that a lot of people write. We've gone and converted it to a script that you can apply. We've taken that to Java code so that people can reuse it, make it a little bit easier so you can refactor, know if you're going to break something out of the box, move it to a project you can promote to a repository, written some tests for it so that we know that it works like we want it to, and then publish it and reconsumed it in the original project, which is kind of where a large-scale organization wants to end up. When you stop at the apply from a script, you can do two different things. You could apply from a URL, which means you'll have no caching at all. So if GitHub goes down for some reason, your builds will just stop working, which is not what you really want to do. You can also do something weird with Git submodules. You could clone a different module in and assert that the values are always right and have some complicated build logic every time you run so that you know that everyone's up to date. But that induces a lot of churn on the developer. So if you do something like this, you can validate that it's always going to be available as long as your internal infrastructure is available. And you have validation that if something goes wrong, you can just go back a version. So if you're using the latest and you found a bug, just go find the one version older, go back to it and tell it report the bug. So if you do a script, you can't really do that very easily. So I'm going to go back to my presentation. And really quickly, we're going to talk about test kit. So like all infrastructure code, it's hard to test something in isolation, especially for Gradle, because you need to occasionally run the entire lifecycle. You've got test kit, which is provided by Gradle now since, I think, 2.6. You've got Nebula Test, which has some great patterns. If you need to do repositories or something like that, you can use those. Great examples. What I usually do is I'll push as much Gradle logic down as far as I possibly can to make a clean interface layer between my business logic and Gradle. That means I can test all of my code completely separate of Gradle's code. Makes it really quick, really fast. I don't have to rely on any of their APIs or any lifecycle phases to be triggered. And then I test that integration layer with the integration between Gradle and the other than my code with an integration test or a longer running test that just does some assertions on values but not running any tasks. You can get a hold of me, LinkedIn, GitHub. This talk was inspired by 2 other things I've written. You can read them. They're probably a lot more elegant than me speaking to you. They also have different code examples, so you can look at them yourself, work through them, things like that. Thanks. Questions?
What were you using in your iTerm 2 to display and type ahead and tree and all
That's just Z shell. I'm just using a different shell from Bash.
So it gives you all those features and displays your GitHub and all that?
Yeah, so I've configured mine to do all this. We can talk later offline about what I'm specifically using if you want to use it. Yep. Yeah. No, you have to install tree, I think. Anything else? All right, cool. I'll give you guys 5 to 8 minutes of your day back. Thanks.